I sometimes think about it like the Android versus Cyborg model. So the Android is okay, it completely replaced you, it's doing everything on its own. But the Cyborg model is like you're in the center and you kind of grafted these systems onto you. And I think it's well agreed upon that like we've been cyborgs for a very long time. Like since the mobile phone, we're basically all cyborgs now.
The Android versus Cyborg. It's a useful frame. The Android replaces you completely. It works autonomously, doesn't need human oversight. That's a dream that some people are selling. But Adam at hyperexponential, an insurance tech business, are building firmly for the cyborg model. The human stays in the center. The AI grafts onto that. They're absolutely clear here. There's always a person in the loop. Adam gives the example of a colleague who's sat next to him chatting nonstop to Claude through voice. That colleague was in control, guiding the flow. For complex insurance, think rocket launches, cyber attacks, skyscraper projects, you can't let the system run blind. The liability is too high. Current headlines may be about replacement, but you need that judgment. What AI does is it frees up bandwidth so that actually people can spend their time on higher level work.
I personally don't think we're in the state at all where you can let the system run blind. And this is really, even in the last few months, everyone feeling, okay, there's been a change from vibe coding to like vibe engineering, where you feel, okay, I can sit in the center. So the Android is okay, it completely replaced you, it's doing everything on its own. But the Cyborg model is like you're in the center and you kind of grafted these systems onto you. Something which is always interesting for me, I think for a lot of people that maybe we're just not really following machine learning. Again, that's why I kind of said I distinguish between like AI as LM versus ML is there are huge parts of our system that are completely autonomous, right? And like ML is extremely powerful and most systems, big systems are running on ML solutions, right? So you don't need humans there. I think it's still pretty early, but in that gap, while it maybe is moving in that direction, I think you can get really outsized gains by taking the cyborg approach, putting yourself in the middle, and then like surrounding yourself with the agents. And I see it day to day. The other day I was working yesterday from a room in there, and a colleague of mine, he is just chatting nonstop back and forth to Claude, and I'm listening to him, he's using the voice mode. And that's it. Like he's gone full cyborg, right? Like his interface now is the agent and it's doing everything. But he's like really guiding that flow. I think there's like two parts that are interesting. One is like the interface. So yeah, like what will the interface look like? I think it started with just like a chatbot, but increasingly it's like not the most ergonomic over time. So in some of our agents, the interface is not a chat at all, right? It's like a traditional interface with buttons and graphs, but there is the ability to talk to the agent inside, either through like some open chat, or I think there's going to be more of like a right-click explain on a lot of things.
I find this fascinating, and it's worth calling out. One of the most interesting things about how HX work with AI is how they get their language models to work in a predominantly statistical field like insurance. Large language models are probabilistic. They predict the next token from a series of characters. They're not actually doing maths. They're predicting text about maths. For an industry built on precise calculations, that sounds like a problem, right? Well, Adam's team solves this in a two-step process. The probabilistic model writes deterministic code that runs the calculations. The AI generates Python scripts, and we all know how well AI can code, right? So the scripts run in a sandbox, the calculation is exact, auditable, deterministic. The hyperscalers are already pushing in this direction with composite tool calling. Instead of calling one tool and then waiting for the response and then calling another tool, they just have it write a script that runs a bunch of tools, gets the answer back, super efficient. It means you can be probabilistic or deterministic as required.
I feel like this is, I mean, I guess it's too much to say it's a solved problem, but when you have sandbox execution environments where it can write a script and then run it and then look at the output, I think it's already past anyone asking the model, like from an agent perspective, asking the model via inference to do mathematics. Because obviously that's not super powerful. And that's also like, again, from a leverage perspective, probably like not high leverage for your tokens, but getting it to write a script and then run that in a sandbox. And you can see Anthropic like is already very clear, like that's the paradigm, because they have their kind of composite tool calling now, where instead of calling one tool, waiting for the response, calling another tool, waiting for the response, because that's token inefficient, just have it write a script, run a bunch of tools, run the calculation, get the response back. So that's auditable, it's traceable, you can see the whole execution, you can see the whole stack call and then present that back to the user. So I feel like it's not such a challenge, I think it's going to get better in that direction. But you just have your agent harness probable or deterministic compute and algorithms for whatever computation you want, and there you go. I think that the world, again, as a utility to the world, insurance companies don't write all of the potential risk they could because of time constraints, et cetera. So there's just like too much for them to handle. And the most compelling thing, and I think that's why language models and agents are so attractive to insurers, is if we take, let's say, World War II, before Alan Turing came up with the first real computer, you had the human computers, right, that would just do the calculation by hand. And underwriters today, that kind of the commercial arm, they are basically these human computers. So they do a lot of these calculations in their head. They have the models and the readers to support them and to help them, but many of them are just on the fly kind of doing this computation from a lot of experience and know-how. But there's a scale limit to what they can do. Right? And I think we will, similar to where you went from humans doing computation and then being the limiting factor, to humans building systems and then orchestrating that to increase the scale. And then obviously computation scaled up like crazy. I think the same thing will kind of happen. I think a lot of the computation that in the specialty space that humans are doing today, those people will start to guide larger systems and then kind of steer, just in the same way engineers steer computer systems.
Think about what this means for the insurance industry. Right now, insurers don't write all the risk that they could. There's just too much coming in, not enough bandwidth to evaluate it all. High quality submissions get buried alongside low value ones, and it's a huge opportunity cost. Adam sees underwriters like human computers. They're doing complex risk computations, often from experience and know-how with pre-AI tools, but there's only so far this can scale. So the initial question isn't whether AI replaces them, it's about scaling. More policies evaluated, more risks written, with the customer firmly at the center.
If you will have agents that are designing, building materials or algorithms, and we start getting into, let's say, space exploration, there's going to be all new kinds of things, capitalistic efforts that we want to go after, that we need to underwrite. So I think there'll be just new kinds of risks as well. Again, I mentioned leverage a number of times, and I really spend a lot of time thinking about because as a startup and as a scale up, you really have to figure out what is the highest leverage thing for you to kind of keep succeeding and winning. And I think if we think about going back to collaboration, kind of modern software teams, you are already in a situation where you could have, let's say, FTMux, you could have 1,000 different shells open with 1,000 different Claude codes running on your code base using Git work trees in order to run those and just keep building the system. So I think the story is that that Claude code built Claude Cowork, I think in 10 days. So that's Claude code building a total other system, no engineer built that. So if you kind of extrapolate that out, you can say, okay, well, we could have literally 10,000 of those. So why isn't it running all the time? And then what's the limiting factor there, and what's the highest leverage? So we spend a lot of time obsessing about that. Our design team spent a lot of time obsessing about, okay, so what is the highest leverage thing for design to do? I think there's no answer. We're all figuring that in real time. But as a lot of things kind of blend and things get flat, it's really interesting to see where we should each have our leverage points.